flux, there will be the induced EMF, and due to that induced EMF, there will be some current in the coil. Okay. Hello Hamza, how are you?
Fine, sir.
So in the last class we have discussed the Lenz's law. Okay. So Lenz's law gives the direction of the induced current. Okay. So according to the Lenz's law, direction of the induced current is such that it opposes its cause, that is change in the flux. Okay. So whenever there will be change in the flux with respect to the coil, with respect to the any wire, okay. So there will be induced EMF. Okay, there will be induced EMF and induced current if the wire is closed or if you have a closed loop. Okay, so we have discussed this. What will happen when we take the magnet in the in this direction, and here is some coil. So in which direction there will be the induced current in the coil. Okay. Just you can revise it. Uh, this is the magnet and you are taking the magnet in this direction. Okay. So what will happen as you are taking the magnet away from this coil, the magnetic flux linked with this coil decrease. So decrease means there will be some change in flux with respect to this coil, means the flux is decreasing, means the flux is changing with respect to this coil. Change in flux with respect to time give you the current in the coil, and that current will always try to oppose the change in the flux. If the flux linked with the coil is decreasing, then the induced current will try to increase the current. Okay, so here uh, south pole will be generated. Okay, south pole will be there. So because here is north pole, here south polarity will be generated. So the south and north will be attract. So the motion in this direction of this magnet will be restricted. Okay, so that is why the current is clockwise. Okay, so direction of the induced EMF. Place your thumb. Suppose this is your magnetic field, and due to this magnetic field, you want to find the induced EMF here. So place your thumb in the direction of the magnetic field. Curvature of your finger will give you the direction of the induced current. So place your thumb in the direction of the magnetic field. This direction represents the inward direction of the magnetic field. This cross means inward direction. Cross means inward magnetic field. And so do your thumb in the direction of the magnetic field and curl it. So you will get this direction, means clockwise direction. The induced current will be clockwise. Here the induced current will be anti-clockwise because the magnetic field in the outward direction. So you will do like this. So this is the first case or the first type of question where the examiner will ask you the direction of the induced EMF. And here you have a magnet and a coil. Now in the second type of questions, see the second type of question. Type second. Here there will be a given magnetic field and a coil. The coil can be of any shape, can be a shape of rectangle, can be a shape of triangle. Okay, and there will be a given magnetic field. So here you will have the given magnetic field plus you will have a coil. So magnetic field, suppose this is the magnetic field given like this. This cross represents the inward direction of magnetic field. Inward direction of magnetic field. and you have a coil like this. Suppose you have a coil like this. This is the coil, and this coil is moving in this direction, moving in this direction. Means you can say this coil is entering, this coil is entering in the magnetic field. Okay. This coil is entering in the magnetic field. So like this. This is the motion of this time. This coil is the rectangular coil. Suppose I have given the name ABCD is a coil. ABC rectangular coil, and here the magnetic field is inwards. Magnetic field is inwards. So now let's see what will happen. You have to tell when this coil is entering in the magnetic field, given magnetic field, you have to tell what will be the direction of the induced current in this coil. What will be the direction of the induced current in this coil? So one by one, step by step, we will see what will happen. As the coil is entering in the magnetic field, as the coil is entering in the magnetic field, what will happening here? The coil will entering in the magnetic field, is entering in the magnetic field. The magnetic field linked with the coil means the magnetic field will increase with respect to the coil. Or you can say, if the magnetic field is increasing from the formula, this formula you can say phi is equal to VA cos theta. So this magnetic flux is directly proportional to the magnetic field. If the magnetic field is increasing with respect to the coil, then you can say the magnetic flux is increasing with respect to the coil. Flux is increasing means the flux is changing with respect to the coil. And whenever there will be a change in the flux, according to the Faraday's law, there will be the induced EMF in the coil, and due to that induced EMF, as this coil is the closed, so here you can say there will be an induced current in the coil. First thing. Now, induced current will be induced. The induced current will be induced in the coil in such a way that that induced current will oppose the change in the flux. Okay. So here the flux linked with the coil is increasing. So the induced current will try to decrease the flux linked with the coil. So that induced current will induce a magnetic field in the opposite direction. Magnetic field in the opposite direction of the given magnetic field. Okay. So here your magnetic field, induced magnetic field, you can say VI. VI is the induced magnetic field will be outwards. So induced magnetic field outwards means positive z axis. So now apply the right hand rule and find the direction of the current. When you will apply the right hand rule as the induced magnetic field in the outward direction, so you will do like this. Your direction of the induced current will be in the anti-clockwise direction. In this direction will be the induced current I. So I is the induced current. So you can say as the coil entering the given magnetic field, the given magnetic field flux linked with coil ABCD will increase and induced current and current will induce in the coil and current will induced in the coil. Okay, so this induced current will try to oppose, or you can write that the induced current will be like that, it opposes the change in the flux. So induced current will try to oppose the change in flux, change in flux linked with coil. So this current will produce the induced magnetic field. Okay, so induced magnetic field. This induced magnetic field will be due to the induced current, because the current can produce the magnetic field. Okay, so induced magnetic field will be in the opposite direction of given magnetic field. So induced magnetic. So direction of the induced magnetic field will be outwards. If the direction of the induced magnetic field will be outwards, then you can say the induced current I will be in the clockwise direction, anti-clockwise direction, anti-clockwise. In this way, you can find direction of the induced EMF, induced current is given by this. Place your thumb in the direction of the magnetic field or the induced magnetic field. Curvature of your finger will give the direction of the induced current. So this is the case where the coil is entering in a given magnetic field, okay, and you have to find the direction of the induced current. So I am taking one question. Here magnetic field is outwards. Magnetic field is outwards. And in this magnetic field, suppose a triangular coil. This is the triangular coil. And this triangular coil is entering. Triangular coil is entering. So this triangular coil is ABC. Magnetic field. What is the direction of induced current? What is the direction of current? Coil. So now you have to find the direction of the induced current in the given coil, as this coil is entering in the magnetic. So again, you can say that as this coil is entering in the magnetic field, the magnetic flux linked with this coil will increase. Okay. So current will be induced in this coil, and the current will be induced in such a way that that current will try to decrease the magnetic flux. So the magnetic field will be generated in magnetic field will be induced like this, that magnetic field will oppose the change in the flux with the coil. So that magnetic field will be opposite to this outwards magnetic field. So a magnetic field will be induced in the inward direction. Okay. So the current will be generated in the coil. So do when you will apply the right hand rule. So magnetic field is inwards. Induced magnetic field is inwards, and you will do your you will curl your finger like this. So you will get the direction of the current like this. So here your magnetic field is outwards. So now answer you can write as this coil is entering in the magnetic field. Okay. So you can write okay. No, do not take. We are not taking this coil is entering. Okay, I am taking that this coil is leaving. Because entering case we have discussed. This coil is leaving the magnetic triangular coil. You can write here leaving. Leaving the magnetic. Now we will tell what will be the direction of the induced current. This coil is leaving the magnetic field, means the flux linked with this coil will decrease. So induced current will be generated in such a way that uh, the flux linked with the coil should increase. So the magnetic field will be induced like this, so that there should be an increase in the flux linked with the coil. Okay. So magnetic field in this case will be produced in the direction of the given magnetic field, so as to increase the flux. Okay. And the given direction of the magnetic field is outwards. Okay. So when you will apply the right hand rule, okay, point your thumb outwards and curl your finger. This direction give you the direction of the current. This direction. Okay. This will be the direction of the induced current. So again, you will get the direction of the induced current will be anti-clockwise. So the induced magnetic field will be outwards, and induced current will be anti-clockwise. You can write that flux linked with coil decrease. Flux linked with this coil is decreasing because this coil is leaving the magnetic field. Okay. Decrease. Induced current will try to induce current will try to increase the flux, linked with the coil. Okay. So magnetic field will be induced. So if we want to increase the magnetic flux linked with the coil, so what we will do? We will increase the magnetic field. So how the induced current will increase the magnetic field? By inducing a magnetic field in the same direction of the given magnetic field. Okay. So magnetic field will be induced in the same direction of given magnetic direction of given magnetic field, that is outwards. So P suffix I means induced magnetic field. Okay, both of you note it down. And if you want to ask any doubt, then you can ask me. Here you have to apply the Lenz law. The current will always induce, note it down, current will always induce in such a way that it will oppose the change in the flux. If the flux is increasing, the induced current will try to decrease the flux. If the flux is decreasing with respect to the coil, then the induced current will try to increase the flux. Note it down. When completed, you can ask me to scroll down.
Done. Sir, done.
Okay, right. So Hamza, getting means you should know when there is a change in the flux. I have told you the Faraday law. There is 3 experiments Faraday have done, and from those 3 experiments, he has concluded that rate of change of magnetic flux will give you the EMF, and due to that EMF, the current will be there in the coil or the wire. Okay, note it down. Note down this. Okay, see once again the direction of how you will how you will find the direction of the induced current. Suppose once again, suppose this is the coil now, and suppose the induced magnetic field. I am saying the induced magnetic field with respect to this coil. Suppose the induced magnetic field due to the induced current produced in the coil, induced current in the coil, due to the induced current in the coil, the magnetic field induced will be uh, outward suppose. So how you will find the direction of the induced current if the magnetic field induced is outward? So outwards means you will place your thumb outwards and curl your finger like this. So the direction of the current, induced current will be like this. That is indicator. If suppose here is the coil and magnetic field induced magnetic field is inwards. Inwards means you will do your thumb inwards. Inwards means away from you, and you will curl your fingers like this. So you will get the direction of the induced current in this direction. That is clockwise direction. Here is anti-clockwise. Here you will get clockwise direction of induced. Okay, so no need to write this. Okay. If you have a wire, suppose we have already discussed this. If you have a wire and this wire have the current in this wire, and suppose I am asking find the direction of the magnetic field at this point P. Find the direction of the magnetic field at this point. So for that, what you will do? Hamza, how you will find the direction of the magnetic field at this point P? You will apply the right hand thumb rule now. Apply the right hand thumb rule again. Point your thumb in the direction of the current and point your finger towards the point where you want to find the magnetic field and curl your finger. You will get the direction inwards. Here the magnetic field will be inwards. And suppose here is some point Q. Then here you will get the direction of the magnetic field outwards. If this wire have the current in the opposite direction, like this, in this direction, if the wire has the current, then suppose here at this point R, if you want to find the direction of the magnetic field, what you will do? You will point your thumb in the direction of the current and you will curl your fingers and you will point your thumb in the direction of the current and point your fingers towards the point where you want to find the direction of the and curl your finger. You will get the direction towards you, means outward. Here you will get the direction of the magnetic field outwards. And here suppose some point S. Here the direction of the magnetic field will be inwards. So this thing you should know. We just note it down, then we will move.
Sir, done.
Okay. So I will use now this concept. So type third question you will get. You will have a wire, current carrying wire and a coil. So you have to tell the direction of the induced EMF when you will increase the current in the wire or decrease the current in the wire accordingly. Suppose this is a wire here and here is some coil. Suppose this is a coil. And in this wire, the current is in this direction. Current is in this direction. Suppose this current I is increasing. This current I is increasing. So we have to tell in which direction there will be the induced current. Hello, Nida, I am discussing this. Okay. I have taken one coil and here I have taken one wire. Okay, this is the straight wire carrying the current. Okay. So this is a straight wire carrying current, and this current is increasing. This time, this current is increasing. So you have to tell the direction of the induced current in this coil. You have to tell. This is A, B, C, D. So this current is increasing now. So what will happen? I am giving you the overview. As the current in the in this wire is increasing, so we know that this current carrying wire will produce the magnetic field around itself. So this coil will be in the region of the magnetic field produced by this wire. So this coil is in the region of the magnetic field, or you can say this coil is in the magnetic field of the wire. So as you are increasing the current, means current, the magnetic field produced by the wire is directly proportional to the magnetic field. Okay. Magnetic field produced by the wire is directly proportional to the current in the wire. When you will increase the magnet current in the wire, the magnetic field around the wire will increase. So you can say when you are increasing the current, the magnetic field is increasing, or you can say the magnetic flux linked with this coil is increasing. The magnetic flux linked with this coil is increasing. Okay. So first thing, here I have written, Nida noted down this thing. If the wire carrying the current in this direction, so the magnetic field here at this point Q will be outwards, and at this point will be at this point P, that is on the right hand side of the wire, will be inward. Okay, so note down this, because I will use this concept here. Here what I have done, I have applied the right hand thumb rule. Point your thumb in the direction of the current and point your finger at a point where you want to find the magnetic field and curl 90 degrees like this. You will get the inward direction of the magnetic field here. Accordingly, you will do here, here, and here. Okay. Now I will use this concept here. So due to this wire, the direction of the magnetic field produced by the wire will be inwards or outwards. See here. This is the wire. Here the magnetic field will be outwards. Okay, so in this direction the magnetic field produced by the wire will be outwards like this. So magnetic field is outwards in this region, and in this region the coil is also present. Okay, so what will happen, as the current is increasing, the flux linked with this coil will increase. So induced, there will be the induced current in this coil, and the induced current will be like that. Induced current will be like that. That induced current will try to decrease the flux. So how the flux will be decreased? There will be some magnetic field induced in the opposite direction of the given magnetic field. This is the magnetic field due to the wire. Okay, this is the magnetic field due to the wire, and induced magnetic field will be like this, out inwards, and inwards means towards the away from you, you can say inward direction. So when you will apply right hand thumb rule, point your thumb in the direction of the magnetic field and curling of your finger in the direction of the induced current. So this is the direction of the induced magnetic field. So do this by yourself. Point your thumb in the direction of the induced magnetic field. Induced magnetic field is inwards, and your sense of curling will give you the direction of the magnet induced current. So induced current will be in this direction. Okay, so now if we know that magnetic field produced by the wire is directly proportional to the current flowing in the wire. Okay, so you can say if current is increasing, current is increasing in wire, then strength of magnetic field, strength of magnetic field will also increase, will also increase. So you can say magnetic field is directly proportional to the current. So next point you can say, so you can say flux linked with coil will increase. So current will induce in the coil. Current will induce in coil. So you can say this induced current will try to decrease the flux linked with coil. So induced magnetic field, you can say induced magnetic field will be in the opposite direction, in the opposite direction of magnetic field due to wire. So magnetic field due to wire will be outwards. So you can say induced magnetic field due to the induced current will be inwards. Will be inwards. So if the magnetic field is inwards, so direction of the induced current will be clockwise. This will be given by right hand thumb. Suppose if the current is increasing in this, if the the current is suppose decreasing in this wire. So who will tell? Nida, tell me what will be the direction of the induced current. This time earlier the current was increasing. Now the current is decreasing. Tell me what will be the direction of the induced current in this coil ABCD. Nida. Very good. Anti-clockwise. You can just use the common sense. Explanation. I am giving the explanation why the current will be anti-clockwise. See, as the current is decreasing in this wire, so the magnetic field here, this magnetic field will decrease, and due to the magnetic field decrease, uh, what will happen? The flux linked with this coil will decrease. So flux linked with this coil is decreasing. So induced current will induce a magnetic field in the direction same as that of magnetic field, because we want to increase that current will try to increase the flux linked with the coil. So how the flux linked with the coil will increase? By increasing the magnetic field. So magnetic field will be increased by uh, inducing the magnetic field in the same direction of the given magnetic. So you can write this: if the current is increasing, if the current is decreasing, sorry, not increasing, decreasing, current is decreasing. So what will happen? You can write magnetic field decrease. So you can say flux also decrease. So you can say induced current will try to increase, try to increase, increase the flux linked with the coil. So induced magnetic field. This time, the induced current will try to increase the flux. How the flux can be increased? And the flux is directly proportional to magnetic field. For increasing the flux, you have to increase the magnetic flux, magnetic field. So induced magnetic field will be in the same direction of the magnetic given magnetic field. So the magnetic field will be added up and magnetic field will increase. So induced magnetic field will be in same direction in same direction of given magnetic field. So induced current will be in the clockwise direction, not clockwise, anti-clockwise. Because induced magnetic field will be this time inwards. Induced magnetic field. Outwards means you will get the direction of the current like this. Okay, so this is the case number type third question. A wire will be given and a coil will be given, and you have to tell uh, the direction of the induced EMF with respect to the current decreasing or increasing. Okay, note it down. We'll solve one question on it. This small I represents the induced current. Now I am taking one question. Suppose the magnetic field is in the outward direction. Magnetic field is in the outward direction. And there is one coil like this. Coil like this. And this coil is moving within the magnetic field. So the coil is moving within the given magnetic field. Given magnetic field. We have to find the direction of induced current in the coil. Now try this question by yourself. Please remember this point. This coil is moving within the given magnetic field. I am giving you the 2 minutes. Try to solve this. This magnetic field is in inward direction. Both of you try this question. No, not ending vortex this time. I was saying the coil is moving within the given magnetic field. This is the point. So I am solving it. If this coil is moving within the given magnetic field, what does it mean? It means that the magnetic field is not changing. Here the magnetic field with respect to the coil is not changing because this coil is, suppose this coil is moved from here to here. Suppose this coil has moved like this. This coil has done the motion. Initially this coil is here. Here the magnetic field is some magnetic field given, and suppose the coil is here now. Here also the magnetic field will remain same. Here also the magnetic field will remain same. So magnetic field linked with the coil is not changing. So that is why the magnetic flux this time linked with the coil will not change. And the induced current in this, there will be no induced EMF and induced current will be zero. Here what is happening? In this case, the current is increasing, so the magnetic field is increasing. So the flux is changing. Okay, here in this case, this coil is leaving the given magnetic. Leaving means the magnetic field is decreasing with respect to this coil. And here this coil is entering in the magnetic field. Okay. Entering means the magnetic field is increasing from 0 to maximum. And what is happening here? Here this coil is moving within the magnetic field, so there will be no change in the magnetic field. That is why no change in the flux. If there is no change in the flux, no current will induce in the coil. So you can say the flux phi is the magnetic flux. Phi is magnetic flux, is given by magnetic field into area into cos theta. So area of the coil will not change, theta will not change. All the things will remain same. So you can say the magnetic flux will be constant when the coil is moving within the magnetic field. If the flux is constant, so you can say there will be no induced EMF. There will be no induced EMF because d phi by dt is 0, no change in flux. Or you can say delta phi by delta t. Delta phi by delta t is equal to 0 because this delta phi means change in flux will be 0. Delta phi will be 0. So there will be no induced EMF. If there is no induced EMF, means there will be no induced current. Simple. Finish. So phi is constant means you can say flux linked with coil is constant. Okay. So note down the answer also. I am giving one more question now. This time, do this question by yourself and try to apply your mind. Suppose the magnetic field is out inwards like this. Magnetic field is like this. Cross means the magnetic field is inwards. And you have a coil, circular coil you have. This is the coil you have. This is the coil. So they are saying uh, the given coil is expanding. And what is the meaning of expanding? Expanding means this. Suppose this is your coil and this coil is expanding is like this. Okay. The area of your coil will increase. The given coil is expanding. Find the direction of induced EMF, or not EMF, induced current in the coil. Okay, try this question by yourself. As the coil is expanding, in the given magnetic field, what will be the direction of the induced current in this coil? First note down this question and after this solve this. I am giving 2 minutes. Tell me the answer. Okay. See this. As this coil is expanding, what is the meaning of the coil is expanding? Means the area of the coil is increasing. You can say area of coil is increasing, and the magnetic field is V. So what is flux linked with the coil? VA cos theta. Here theta will remain same. Theta will remain same. The magnetic field will remain same. But this time your area is increasing. If your area is increasing, means your flux is increasing. Area is increasing, so you can say your flux is increasing. As area of coil is increasing. From this formula, if this area is increasing, means the flux is increasing. If the flux is increasing, okay, with the coil, then there will be the induced current in this coil. There will be the induced current in this coil. So the induced current will be induced in this coil like that. This induced current will try to decrease the flux linked with the coil. So the induced magnetic field due to the induced current will be in the opposite direction of the magnetic field. Okay, so the induced current in the coil will be, see, this direction represents the outward direction. So point your thumb in the outward direction and curl your fingers. Sense of your curling your finger will give the direction of the induced current. So you will get the direction of the induced current anti-clockwise. Because the direction of the induced magnetic field will be this, anti-clockwise. So I, you can say induced current will be anti-clockwise. I represents the induced current in coil. Note down this. So Nidha, tell me if this coil is compressed. This coil is compressed. What will be the direction of the induced current? Compressed means you can say the area of this coil is decreasing. So what will be the direction of induced current at that time? Simply clockwise. Fine, right. Current will be clockwise. As this area is increasing, decreasing, Compressing means area is decreasing. So as this A is decreasing, so this file phi will be decreased. Phi will be decreased. Induced magnetic field will be in the same direction of the given magnetic field. When you will apply the right hand rule, you will get the clockwise like this. Okay. So there is one node point, and I will use this node point. Direction of magnetic field. Direction of magnetic field for circular coil carrying current. Earlier also I have discussed this, but I am telling it again. Circular coil carrying current. So if you have a circular coil like this, and if the current in this circular coil is in this direction, and at the center of this coil, what will be the direction of the magnetic field? Hamza, can you tell me what will be the direction of the magnetic field at the center as the current in this coil is in this direction? Very good, Hamza, very good. Well done. Inwards. Who have told you? Oh, Nida told. Okay, Nida, right. Inwards. Because what you will do, you will use again right hand thumb rule, modified right hand thumb rule. See here, you can. I have told you. I think. Okay, no problem. So curl your finger along the sense of current, and the curl your finger along the sense of current. So your current is in this direction along the sense of current, and you will get the direction of the thumb. Then the direction of the thumb is inward. So that is why the magnetic field will be inward here. Magnetic field will be inwards. So if I am taking the coil, and if in this coil the current is in this direction, in that case, the direction of the magnetic field will be outwards. Direction of the magnetic field at the center will be outwards. Now, if you want to find the direction of the magnetic field, curl your four fingers along the sense of current. The thumb will be outwards. Okay, Hamza? Getting?
Yes, sir.
Okay. This direction is given by again the right hand thumb rule. Use modified right hand thumb rule. Now I am taking one question and I will use this concept. Here a battery is connected. Here I have connected a key. This is your key. And this time, this key is open or this circuit is open. And this is your coil number 1. And this is your coil number 2. Coil number 1, coil number 2. Your battery is connected. Your key is connected. This is your coil number 1. This is your coil number 2. Okay. This is the center. This arrangement is given. And they are saying calculate direction of induced current in coil second if key is if number 1 key is just closed. Key is just closed. Number second, they are saying after the closing, now they have closed the key. Now they are saying key is just open. Open. Third part, after long time being the key is closed. It's closed. So 3 cases are given, and in all of the 3 cases, we have to tell what will be the direction of the induced EMI in the second coil. So first note down this question, then I will solve it. Both of you note down. there are two circular coils and uh, connected with some battery. This whole system is connected with the battery and a key is there, and you have to find the direction of the induced current in the coil number second, this coil. When the key is just closed, when the key is just opened, and after a long time being, the key is closed. Nida completed this. Okay. So now see, first part. So see, what will be the direction? When the key will be closed, what will happen? The current in the first coil, when you will this key, when you will close this key, okay, so this will become the closed circuit, and here is a battery. Due to this battery, the current will flow in this circuit. So means the current will flow in this coil. Current will flow in this coil like this. So due to this current, as the current is flowing like this, due to this current, there will be some magnetic field. There will be some magnetic field around at the center. There will be some magnetic field, and that magnetic field will be in the just when you will apply the modified right hand thumb rule on this coil. Okay, see here, if the current is in this direction, current is in this direction, then the magnetic field is inwards. Okay, here the current is in this direction, the magnetic field will be inwards. Okay, magnetic field is inwards. First case, magnetic field is inwards, and this current is increasing from 0 to the maximum. Means you can say the magnetic field is increasing from 0 to maximum. The flux linked with the coil number second, the flux, actually this coil number 2 is in the magnetic field of coil number 1. As the magnetic current is increasing, this magnetic field is increasing. So the magnetic flux linked with this coil is increasing. So the induced current will generate the induced magnetic field in the opposite direction of this magnetic field. So your induced magnetic field will be outwards. Outwards means the current will be in the anti-clockwise direction. Okay. The, uh, the, the induced current will be in this direction. You can draw this figure for that. Okay, so you can write the answer now. When the current in the coil, let's say current in coil 1 will increase from 0 to maximum. So you can say magnetic field will also increase. because magnetic field is directly proportional to current. When this magnetic field will increase, and this coil is in the magnetic field of the coil number 1, so magnetic, you can say magnetic flux linked with the coil number 2 will increase. Magnetic flux linked with coil will increase. So induced current will be there in the coil number 2, and that induced current will induce a magnetic field in the opposite direction of the given magnetic field. So induced current will induce a magnetic field in the opposite direction of magnetic field of coil. That is outwards. So you can say your induced current will be anti-clockwise, given by right hand from left. This is the first answer of the first part. Second part you will do by yourself. Third part I am solving. They are saying after a long time being the key is closed. Suppose the key is closed now for 50 minutes. Okay. The key is closed. So what will happen? The key will close. The current will be maximum in the circuit. Okay. The current will be some constant value. The current, now the current will not increase or decrease. So in the same way, you can say the magnetic field will not increase or decrease. The magnetic field produced by this coil number 1, okay, will not increase or decrease. So you can say the flux linked with the coil number 2 will not increase or decrease, means the flux will be constant. And what will happen when the flux is constant? This is the case. Here, the flux is constant, so EMF is 0, induced current is 0. Third part, you can say the current will remain constant. If the current is constant, then you can say the magnetic field will be constant. If the magnetic field is constant, then the phi will constant. If phi is constant, then the induced current in the coil number 2 will be 0. Okay, note down this. Now this time the key is closed. Just connect this key. Second part you will solve by yourself. V suffix I is the induced magnetic field. And small I is the induced current. Okay. Second is clockwise. It is obvious because this is anti-clockwise, so that will be clockwise. Why? Because the current will when this you will open this key for a moment, then the current in this coil, this current will be decreased. As the current will decrease, the magnetic field, this V is the magnetic field produced by the coil one. V is the, you can write the magnetic field due to coil one. So this V will decrease. If this magnetic field decrease, then the magnetic flux linked with the coil will decrease. So induced current will try to increase the magnetic field. So induce, okay, try to increase the magnetic field. And due to this coil number one, the magnetic field is in the inward direction. Magnetic field is the inward direction. So induced magnetic field will also be in the inward direction. So when the magnetic field, induced magnetic field will be inward direction, you will apply the right hand rule. Point your thumb in the direction of the magnetic field, okay, inwards, and curve like this. So this direction means the clockwise direction will be there for the coil number second, induced current, for the second part. Okay, write down this now. And third part is very, very easy because there is no change in the magnetic flux linked with the coil number second. So that is why the induced current in that case is zero. This is right hand thumb rule, right hand thumb rule. Current is constant in the third case. So the magnetic field. Okay, done. Okay, if both of you means have any doubt, then you can ask me. Otherwise, we will meet in the next class. Okay. And revise your notes properly before coming to the class. Okay, Hamza and Nida, both of you. Homework question of the last class. I have given the homework in the last class. Okay. This question. Okay, that thing we will discuss in the next class.